last new part for now with our graphing. We've done a lot of stuff. I mean, we've done domain, we've done range, we've done end behavior, we've done mins and maxes. Now, the last piece is finding what are called zeros, which another name for that is going to be called an x-intercept. Where's across the x-axis at? Hey, look at that. That even mentions for my first blank here. Led right into that. So, finding zeros, as you're going to find out a little later in the unit, is another way of finding answers. We're finding answers without having to do a bunch of algebra to do it, which is kind of nice. So, I'm going to write in this next blank, but I'm not expecting you to kind of deal with something like this. This is more of a explain it later. A polynomial of degree n, you just fill in a number, degree 3, let's say, can have at most n real 0. So here's what that means. If I have a polynomial, the largest exponent is 3, the most I can have is 3 answers. If the largest exponent is 4, I can have 4 answers. This is wild. If it's 2, I can have 2 answers, and so on. And so we can get some hints based on whether or not my polynomial has an even or an odd degree. So reminder again, even, we're talking numbers like 2, 4, 6, okay, even numbers. And odd, and then we'll get to the blanks. We're talking like 1, 3, 5. Good to have those there just as a reference. So an even degree polynomial, this is going to seem weird, has an even number of zeros. Okay. An odd degree polynomial has an odd number of zeros. Now let me try and explain that a little bit better here before we go on. So for instance, let's do this one on a sticky note for now, because we're going to do that on these next couple. So let's say I had something that looked like this. Okay. My degree is 3, which means nobody might come in a minute though, so I'll hang on to it just in case. So this means since the degree is an odd number, you would have an odd number of zeros, which means this would have 1 or 3 zeros, or 1 or 3 answers to it, which seems strange, but that's going to lead into something. Or like if I had y equals x squared plus 3x minus 7, okay, since my degree is 2, I could have 2 answers, or I could have 0 answers. You're like, no, wait. This is getting weird now. How in the heck do you have 0 answers? That will come into something that we call complex or imaginary solutions. That's a little further down. the road. All we're going to need to deal with right now is just knowing that even is even, odd is odd. They go together for right now. Now you're going to get to see it in action. Graph the function and identify the zeros. If you have not grabbed a handy-dandy calculator, again, why not? We're going to clear out all the crazy stuff they were doing last hour in here. I would also suggest doing a Zoom number 6, a Zoom standard, because who knows what craziness was in the calculators earlier in the day. This way we're all on the same page. Okay, so once we're all on the same page, all our graphs are 10 by 10s like this. Back to y equals we go. If there's still something there, clear it out. Here's what we're rolling with. X to the third plus x squared minus 2x. Again, minus, not negative. The calculator does care about that. So let's take a peek at it first. Okay, so I'm kind of looking, I'm like, all right, it's kind of curvy and stuff. And just like we did before, we're going to use the chart, or the table, which is second and graph, to plot as many points as we can for this particular picture. And I think we're going 10 by 10 here. So I'm going to kind of go... I'm kind of faking it on this first one. 12's a little off, but that's okay. We're going to make it work. -2, 0. -1, 2. 0, 0. You don't even know yet that we've hit the jackpot, but I'll discuss that in a minute. So I'm going to plot all the ones that are reasonably within getting into my picture. I'm going to look at my picture again so I can make this work. Oops, that was supposed to be negative. I didn't do it. All right, so we're up, we're down, back up. Okay, so if we were doing all the other stuff, end behavior and max, we'd have min, we could do all the things. But right now, we're just looking for zeros. So remember, here, if you have zeros, you're going to look for y equals 0 in the chart, because if it's y equals 0, it's crossing the x-axis. So you're like, wait a minute. Let me get back to my chart here for a sec. Hey, check this out. Any coordinate mentioning coordinate that has a y value of 0 is going to be a solution for you. And here's the cooler thing about it. Normally, since my degree was 3, my biggest exponent was 3, it would mean that more times than not, there's going to be 3 answers. Guess what? 1, 2, 3. There they are. I'm done. That was about as good as it gets. That was pretty slick. Now, am I going to get that fortunate every time? Maybe, maybe not. And I'm going to show you what to do if the maybe not comes into play here in just a sec. I just want to look at one thing. Okay, that's what I wanted to see. So I look at this next one, and I go, okay, well, let's get this in. So negative, not minus, negative, x to the 4th, arrow down, so make sure, again, double check, make sure your exponents are right, your signs are good, all that stuff before you get too far in here. So once we get it in, let's kind of see what she looks like. So I look and I go, okay, so normally here, my biggest exponent was 4. So it'd be degree 4. So there might be 4 answers, might be 2 answers. It depends. So let's see, when we go to get our chart up, because we want to graph this stuff, what we happen to find. Like, those are the only 5 points that tend to show up on my calculator here that are going to be helpful. So I'm like, okay, so I can handle this. But the important part was, how many zeros did I find? So we found 3. We've got one at -1, 0. We've got one at 1, 0. We have one at 3 zeros. And you're like, well, wait a minute. You just got done saying there was 2 answers, or there's 4 answers, and I got 3 answers. What the heck? You actually did get 4. Let me explain. If you have one of your answers that bounces off the axis, in other words, Like this one, it went straight through and then went on. It went straight through and went on. This one hit the axis and then bounced back up. That one right there is called a double root, which means it counts for two answers. So this has two names it could actually have. It could be a double root, or something that we're going to call in a little while when we get to the back of this note sheet, something called multiplicity. It means the answer counts more than once. So we actually do have 1, 2, 3, 4 answers. But let me show you one other thing while we're here, and I wish I'd have had a bad zero show up. So let's say we're back here at the graph, and one of my zeros, I couldn't find it. So here's where I'm going to bust out one more thing to help me. And you might want to jot this down. You're like, oh, not this thing again. Yeah, this thing again. If I'm looking for an x-intercept, if I'm looking for a 0, we can do that the exact same way we've been doing all this other stuff. So in other words, I could do second trace 0. And let's say I was looking for this one on the left. I'd get as close to it as I could. It won't be perfect. And then we're going to do the arrow game. Left, 1, 2, 3, enter. There's my boundary. Right, 6 times, 1, 2, 3. Back where I started. 4, 5, 6. Enter. There's my second boundary. And enter, and there's the -1, 0. Now I know I got it straight from the chart, but if I couldn't get it from the chart, that's what I'd do. I'd do the exact same thing we've been doing for like a couple of days now. And this will show up on the review again tomorrow as well. So that's one way I can find the zeros, by looking at the graph or looking at the chart when I get there. Here's another way you can do it. Oh, first time this semester. Here it comes. The linear factors of a polynomial can be found by writing the polynomial in factored form. It's back, the Algebra 2 F word. Here we go. So these are the things where we're going to have to do a little bit of mental math. But the first question we always ask, do all of my terms have anything in common? They may not sometimes, but sometimes they will. So if you look at this, you're like, x to the third, they all have x. So we're going to take one x out, and we're going to take one away from each of these. So my new job is to take what's in the parentheses. Maybe this will strike a bell when I do this. What multiplies to 15, 3 and 5. Now again, if you still have your multiplication chart from last semester, cool. If otherwise, I can get some more. That's not a problem. Now, here's the question though. Okay, so 3 times 5 is 15. I can get to 2. That -2 means that's the sign of my bigger number. So -5 and +3. So check this out. It's a degree of 3. I should get 3 answers. X equals 0. There's one answer. X plus 3 equals 0. So x equals -3. 2 answers. X minus 5 equals 0. X equals 5. But remember, when you're naming zeros, okay, I'm not going to be a stickler about this yet. If you just write 0, -3, and 5, I'll take that. But I would prefer that they're all coordinate points, because that, to be honest, is more of what I would want. But I'll take either. Right now, we're just content with we got to find the answers. So you're like, crap. If I don't like doing, factoring, what do? Hope you can find them on the calculator, because sometimes you're going to have to be able to do that. That's just going to be part of what we do. So we'll work at that some, though. We'll get you there. Okay. One last piece of the puzzle here with all this, and I was referring to it a little bit earlier. And this should keep us at our 20 or under here, hopefully. Multiplicity of a zero is the number of times its corresponding linear factor occurs. In other words, how many times it crosses the axis. So here this is, write it in factored form. You're like, okay, hey, they all have an x in common again. Are they going to have an x in common every time? No. Will they a lot of the time? Yeah. So if they have an x in common, we'll just take one away from each one. We're back to the factoring train here. So multiply to get the number on the end. Add to get the number in the middle. Same two numbers. So what could multiply to positive 9 and add up to negative 6, negative 3, and negative 3? Because negative times negative is positive. And if I owe my friend $3 and I borrow 3 more, I owe him 6 now. So I've covered both. But we're going to write this a little bit differently. Since these parentheses, these quantities are the same, I can write that as x minus 3 squared. And here's why that's important. If I set x equal to 0, okay, I got an answer, but I only got 1. So that multiplicity counts 1 time. Okay? But if you take that x minus 3 and set it equal to 0, you get x equals 3, but that exponent that's there will tell you the multiplicity of that one. That one have a multiplicity of 2. That way, 2 plus 1 gets me 3 answers. Kind of like that one we had on the graph in the front, except we didn't see this. We didn't see it except for the bounce off the calculator. So, one more time to the graph. Because you're like, wait, that's the same thing. We already know the answer. We do, but we want to get used to seeing it on the screen too to give us another option. So we got x to the third minus 6x squared plus 9x. We're going to take a peek at the graph. And now we're going to get to see the multiplicity at work. Because when I put my zeros in this time, and let's get a couple more points here. Let's see. Ooh, that's way down there. Okay, that should help. So we're going up and down and back up. So, what did I notice? Well, hopefully, as I start to look at the picture once I get it on there, when the graph goes through at x equals 0, it goes straight through. Whoop, there it went. Went through, didn't stop, didn't do anything. Okay? Multiplicity of 1. It went through there 1 time. At 3, though, it starts to come down. It just kisses the x-axis and goes back up. If you get that bounce, where it just hits it and then goes the other direction again, that's where your multiplicity is coming in. So, if the multiplicity is odd, the graph crosses that 0. So that would be an example of an odd multiplicity. It went straight through 1 time, there it is. If the multiplicity is even, it bounces off the 0. Like we did over here at 3. Okay? Having this should help everything. Odd goes straight through, even it bounces. And that's going to be true every time. So does that mean I have to do this fancy graph thing every time? No. Sometimes, if they're factored for us already, we hope they're already factored for us, I can look at this. I can set the set of parentheses equal to 0. So I'm just going to do these one at a time. You're like, Hardy, where'd the squared go? That'll come back. Solve the mini equation. Okay, so my 0 is at -7. The multiplicity is the exponent on that particular set of parentheses. So here my multiplicity would be 2, which is even, so it bounces. That's all you're having to do with these. Okay, we take the set of parentheses, we set it equal to 0, we solve the little mini equation. Okay, that ends up being our 0. If I don't see an exponent on it, we assume it's just 1. 1 is an odd number, so it crosses. Okay, those are the only two choices for a fact. There is no third choice. And then the last one, I'm going to try and squeeze it in here. So my last 0 is 4, but its exponent is 3. Which is odd. Even do this again if you need to up here with odd and even. That's fine. Is odd, so it crosses. So if it's factored already, great. We use it. We go about our business. If it's not factored, we do like we did above and we factor it to the best of our ability. Or if all else fails, stick it in the calculator and see if you can find your zeros that way. This time, I got x squared I can take out of all of them. That's the smallest exponent I have. So I'm going to take 2 away from each of these. And then I got to factor what's left. So again, we try to reference back to first semester, like, okay, I multiply to a negative. I know it can't be both negative. That'd make positive, so it's got to be one of each. There we go. 4 and 2 get me to 8. 4 and 2 can get me to 2. That's the sign of my bigger number. So I have all the pieces. And just like we did up here, you're like, well, like even with that I do it? Yeah. If x squared equals 0, last I checked, if I square 0, I still get 0. So you're like, okay. The multiplicity, you still look at the exponent. So it's 2, which is even, which means it bounces. So we're on the same path we were before. Everything gets set equal to 0. If you don't see an exponent, that's always going to be a 1, which is odd. I'll even show you how to do it with the calculator in a sec, in case you want to go that route instead. There's always going to be a way to get there. Exponent is 1. It crosses. So just to show you quick, if you're like, I hate factoring, Hardy, I don't want to factor, is there a way I can get around this at least some of the time? The answer usually will be yes. So if I graphed it, I would notice there's a 0, there's a 0, there's a 0. So let's look at our chart. Maybe. Come on, chart. -2 is a 0. 0 is a 0. 4 is a 0. So I could get those straight from the calculator. And then I'd come back here and I'd say, okay, at -2, whoop, it goes straight through. Okay, excuse me, at -2, it goes straight through. It crosses. At 0, oh, boing, it bounces off the axis. And then when I get to 4, straight on through. So you can use the calculator if you need to, okay, to get to that last part. All right, last thing. I appreciate your patience on the beginning of a week here. It'll be paid off by not having to listen to as much Hardy gibberish tomorrow. A polynomial function has a 0 at -6, multiplicity of 2. Okay, quick note on this one. I'm going to write it out, and then we're going to see what weird things are going on. You're like, Hardy, it said 0 at -6. Why did you put +6? I'm going to explain. And a 2 of multiplicity of 1. Again, Hardy, you flip the sign. Why are you flipping the signs? Okay, here's why. You notice how here when I got an answer of -2, you look at the step before it was x plus 2? Or here I got an answer as x plus 4, the step before was x minus 4. You're going to switch the sign when you go to put it in the parentheses. So if it's -6, you put +6 in the parentheses. If it's +2, you put -2 in the parentheses. And multiplicity just tells you what exponent to do. So then it says, write a polynomial function in standard form that could represent it, which means we've got to multiply this out, if I can spell. There we go. Multiply this out. Here's the one bit of bad news. There's only one. Hardy, can I just distribute the squared here? I can't. So here's what we're going to end up doing. We're going to write that x plus 6 twice. And once we do that, we're going to do this a piece at a time. This is the most time-consuming thing we do. So we're going to distribute the x. So x to the second, distribute the x, plus 6x. Do it again down here. We did this back at the beginning of the unit. Distribute the 6 to both terms. And put it together. In other words, put my middle terms together. You're like, oof, da Hardy. I feel the same way. I do. You're like, wait, so I got to do it again? Yep, one more time. Last time. You can decide how you want to do your distributing. I like doing smaller to larger. So I'm going to distribute the x. I'm going to add an x to each of these. And then I'm going to do the same thing with my -2 all the way through. So -2 times x squared, -2 times 24, times 12x, I was thinking ahead, and -2 times 36. That, ladies and gentlemen, is a whole lot of stuff to deal with. And then we just combine the like terms. So this would be the polynomial function in standard form, biggest exponent to least, that we get coming from those. So again, except for this, there's not a lot of work to this. It's just kind of looking at charts, seeing how they work, punching it in the calculator maybe, seeing what's going on with those to see, are we feeling all right with stuff. So here's the dealio. You're like, you're throwing practice in on this, aren't you? Yeah. So you get to pick. Over in the practice on 9 and 10, your choice, evens or odds. I'm asking for 5 problems. I don't think I'm asking for too much. I have answers posted for both. But I want you to do, if you do a handful of these, and there's a little bit of review with end behavior and some of that stuff, you're going to be ready for this preview tomorrow. You're like, this is easy. I like this. Bring on the quiz. Let's get on with some other stuff. So, again, keep your practice out. Have it ready. Check things. Because, again, you're going to have your notes available to you during this quiz. So the more you know now about how to use them, the better off you are going to